Inside your body, right this very second, there's a silent war being fought. The fighters are totally microscopic, the battles go completely unnoticed, and right there on the front lines are your body's elite defenders, antibodies.
I mean, think about it. Every single day, you're under assault from countless invaders, viruses, bacteria, you name it. And the reason you don't even notice most of the time is all thanks to these unsung molecular heroes. So, what exactly are they? And how in the world do they keep you safe?
Okay, so at its core, an antibody is a special kind of protein, and it's built by our own white blood cells. Its whole job, its entire mission, is to find and grab onto anything the body sees as foreign, what scientists call an antigen. But here's the magic trick, its specificity. Each antibody is like a unique key, and it's been perfectly, and I mean perfectly, crafted to fit only one specific lock.
Now, you might hear a couple of different terms for these proteins: antibody and immunoglobulin. They can be a little confusing, but here's a super simple way to think about it. Immunoglobulin is the big family name, kind of like the word dog. Antibody, on the other hand, that's a specific type with a specific job, like a terrier. So, all terriers are dogs, right? But not all dogs are terriers. We're focusing on the terriers today, the ones specifically trained for defense.
Figuring all this out took scientists decades. It actually started way back in 1890 with the simple proof that something in our blood was protective. But it took all the way until 1959 for the real breakthrough. That's when a scientist named Rodney Porter used enzymes like these tiny molecular scissors to literally snip the antibody apart. And by doing that, he revealed it had different parts with different jobs. And that discovery, that was a total game changer. It's the key to everything we're about to talk about. So, let's take a closer look at that famous Y shape. Why a Y? Well, it turns out it's not random at all. This shape is a perfect piece of molecular engineering, where the form is dictated entirely by its function. It's beautiful, really.
So the blueprint for this Y is actually pretty simple, but it's incredibly strong. It's made of 4 protein chains, 2 long, identical heavy chains that make up the main body, and 2 shorter, identical light chains that finish off the arms. And see those disulfide bonds? Think of them like molecular rivets, just locking everything tightly together. And you'll want to pay attention to those heavy chains. Their structure is what ultimately decides the antibody's class and what its specific mission is going to be.
This Y structure basically gives the antibody a split personality. You've got the tips of the Y, the variable region. You can think of these as the grabbers. Each one is uniquely shaped to bind to one specific target. But then you've got the stem of the Y, the constant region. This is the command center. It doesn't grab anything. Instead, once the grabbers have locked onto a target, this part sends out the signal to the rest of the immune system, telling it exactly what to do next.
And that brings us to the antibody army itself. Because, you see, there isn't just one type of antibody. Our body actually deploys 5 distinct classes, and each one is a specialized unit with a totally different structure and a different mission. So check out this chart. It gives you a quick look at the 5 main classes. You can see right away they're different. I mean, look at IgM. It's this huge 5-unit structure, while IgA forms a 2-unit pair. They also have different missions. You've got IgE fighting parasites and causing allergies, while others are guarding your gut. And here's an incredible detail. See that last column? Only IgG can cross the placenta to protect a newborn? Just amazing. Okay, so let's zoom in on the 3 most common classes and see how they really operate.
First up is IgG. This is the true heavyweight champion. It makes up something like 80% of all the antibodies in your blood, and it's the absolute key to long-term immunity. This is the one your body relies on for its memory. And yeah, this is also that amazing molecule that can cross the placenta, giving a mother's immunity directly to her baby.
Next, we've got IgM. Think of IgM as the immune system's SWAT team. When a totally new invader shows up, IgM is the very first on the scene. It forms this massive 5-unit structure that's just incredibly good at grabbing and neutralizing threats during that critical first wave of an infection.
And finally, for our big 3, there's IgA, the gatekeeper. Its job is to guard all the entry points to your body. You'll find it in your saliva, in your tears, and lining your gut.
By standing guard right at the entrance, its whole goal is to take out threats before they can even get a foothold inside.
So, how are these incredible molecules even made? Well, it's not a solo act. Not at all. It's more like a finely tuned orchestra, and it takes the precise cooperation of 3 different kinds of cells, all playing in perfect harmony.
So it all starts with a scout, an antigen-presenting cell that finds an invader, gobbles it up, and then puts a little piece of it on display for other cells to see. Next up is the conductor, a helper T cell. It recognizes that piece and sends out chemical signals to activate the factory. And finally, you have the factory itself, a B cell, which gets the signal, starts multiplying like crazy, and turns into what we call plasma cells, which can then churn out thousands of antibodies per second. It's just an unbelievable production line.
All right, so once these antibodies are made and deployed, they don't just have one way of fighting. Oh no, they have a whole battle plan, a full arsenal of different strategies they can use to neutralize threats. So how do they actually win the fight? Well, they've got 4 main tactics. The simplest is neutralization. Basically, just physically getting in the way, blocking a virus so it can't get into our cells. Then there's opsonization, which is like painting a big bright "Eat Me" sign on an invader for other immune cells to find and destroy. They can also trigger complement activation, which is a whole cascade of proteins that literally punches holes in bacteria. And finally, they can act as a bridge, guiding our body's own killer cells directly to an infected target to take it out.
But maybe the most incredible, the most powerful ability of this whole system is its memory. This is the ultimate defense. It's the very reason you hardly ever get the exact same cold twice. And it's the fundamental principle behind how all vaccines work.
Think about it like this. When your body sees an invader for the first time, its response is a little slow, a little weaker, and it mostly uses that first responder, IgM. This is the learning phase. But the second time it sees that same invader, the response is lightning fast, way stronger, and it just floods your system with that powerful, long-lasting IgG. The immune system has now entered the expert phase. This ability to remember, that's what gives us long-lasting immunity. It's basically the immune system looking at an old enemy and saying, "Oh, I remember you, and this time, I'm ready." It is just a powerful, elegant defense that protects us for years, sometimes even for an entire lifetime.
And this all brings us to a final thought to leave you with. We've seen just how incredibly specific and adaptable these antibodies are. So as our understanding gets deeper and deeper, you have to wonder, how might we engineer these molecular guardians in the future? Could we use them to fight new diseases, to tackle cancers, maybe even to create truly personalized medicine? The possibilities, well, they feel just as vast and complex as the immune system itself.